The next speaker is Jean-Pierre with the talk, The Elimination of the Holism-reductionism dichotomy through the analysis of quantum chemistry.
It is a pleasure to see you after a long time. So I would like to address to the whole community a warm thought. And I hope that you are well and that your relatives are well as well, okay? Truly and sincerely. And we are living in a very dark period for humanity. So a special thought for all of you. Okay, and then special thanks to Olympia and her team for organizing this meeting, and especially in the situation we are living. Okay, so I share with you two pictures. Okay, as you know, I am symbolic. I like to use symbol in order to share things with you. Okay, I would like also to dedicate this talk to my colleague and Professor Romero. First of all, I would like to explain the context in which this work takes place. Olympia and Juan Camillo have invited me to work a paper in their book. So it was for me the opportunity to resume previous work, and why including new dimensions for this work, because I come back to chemical laboratories in order to scrutinize what chemists are doing in their everyday practices. And I also keep on widening my mind, learning different things from biology, scientific ecology, philosophy, and so on. So in line with Eric sharing, my idea is to learn and to scrutinize from chemical practices. What are chemists doing? And then to reflect upon what science and technology are now doing, and to face the philosophical issues they raise. Okay, the title of my presentation was inspired by Carnap, Elimination of Metaphysics through the Logical Analysis of Language. I am more and more attracted by analytical philosophy. It is a very important change for me. I have divided my presentation into three parts. First, I would like to provide clarification and to limit the scope of my reflection, then to come back to laboratories and to share concluding remarks. Clarification. First of all, as you know, there are different interpretation, different schools of reductionism and holisms, but whatever may be said, all of them share basic ideas. For reductionists, you can divide a whole into its parts. There is a prevalence of parts. And if you know parts, you can deduce or explain the wholes. And conversely, for holistic presentations and interpretations, you have to consider the whole in order to determine the parts. And the whole is not the sum of the parts, and it can even be more than the sum of the parts. We have to bear in mind that there are different versions, ontological, epistemological, methodological. Okay, ontological aspect is with things of the words, object of the words, their properties. What is the word made of? Epistemological aspects deals with knowledge we gain about things, okay? And the reality, that is to say, the way we describe the word. And methodological aspect deals with scientific investigation. How scientists develop methods in order to understand, to explain, to predict what occurs in the world, okay? So here my work is not to defend or to attack any form of holism and reductionism. It is not what is of importance for me. S'il vous plaît, je suis en conférence là. S'il vous plaît, on vous entend. Sorry, I have a problem. So here, I simply investigate what chemists are doing, okay, when they calculate something, for example, a geometry, when they determine energy. First, scrutinizing what they are doing, and then developing ideas or analyzing what philosophers say about science, okay? Now come back to the laboratory. There is a seeming prevalence of works of our parts depending on the approaches at stake under investigation. If we consider the very first methods used by quantum chemists, that is to say, valence bond approach or the molecular orbital approximations. In the case of Pauling considers a molecule to be a sum of atoms, okay? So he developed a kind of Daltonian scheme in which a molecule is an aggregate, okay? Conversely, Malakine considers a molecule to be an entity in itself. So when you study a molecule, you have to study the reactions to which this molecule participates, okay? And considering a molecule to be a sum of atoms could be, in the best case, an approximation, but just an approximation. It is interesting to see now, for example, that there is a seeming opposition in current quantum theory of atoms and molecules. I share with you this quotation from Bader and Mattel. And here, the vocabulary is different. There are topological atoms, to refer to Jesus' presentation, previous presentation, and you can divide a molecular space into different topological atoms, okay? And as those atoms are separated one from the others, you can calculate a molecular properties considering the sum of atomic properties. This is a kind of seeming reduction. Now, if we consider the way those chemists calculate the different values of the, for example, here we have the molecular approximation of Malakine. On the left-hand side, you have a molecular wave function, and on the right-hand side, it is written as a linear combination of atomic orbitals. In a way, you can say, oh, we have written a molecular function as a sum of atomic functions. So we can reduce, you can deduce a molecular feature characteristic from atomic ones. But if you consider the way the calculation is carried out, it is not the case, because chemists use methods of minimization, okay, what we call variational methods. And if we consider the technical different steps, you see that when you determine the coefficient, the weighting coefficients, you have to consider characteristics of the whole molecules. So here you have not the reduction of the whole from its parts, from a molecule to its atoms, but at the same time, the whole and the parts and the surroundings are required in order to fulfill the calculation. And it is interesting to see that Pauling used the same minimal variational methods for other kind of calculation, okay? But using the same methods imply using the same explanation. So in both cases, the whole, the parts, and the surroundings are required into a calculation. So the whole is not eliminated by the parts in Pauling situation, and conversely, the parts are not eliminated by the whole in the case of the molecular approximation, or the molecular orbital approximation, okay? In the same case, in quantum theory of atoms and molecules, there is a discussion between Sheriff and Bader and Popelier. Popelier has pointed out the fact that we have to qualify some results insofar as electron density depends, local electron density in a way depends on the whole electron density. So if you think that you can reduce the molecular space by adding topological atoms, you have at the same time to be aware of the fact that electron density, even locally, contains information coming from the whole molecules. And in these methods too, the different chemists use variational methods. So we have to qualify for the whole discussions. There are not wholes and parts only. Or the whole doesn't prevail and the parts don't prevail. We have wholes and parts and the surroundings in the very calculation. I would like to, just as the last point of this part, to describe how chemists perform a calculation. What do they do, in fact? They enter data concerning each atom in the molecule. They enter in the computer its specific effects within the molecules. They enter data about the whole molecule. And they enter data about the way the molecule and the study interact with the surroundings. So here you have the parts, you have the whole, and you have the surroundings into the calculation. And then you can use function called bases. You can use variational techniques in order to reach a value of an energy or a specific geometry. There is an interactive calculation, loops of calculation or carry out, and there is a kind of convergence. If the convergence is impossible, practitioners have to change parameters in order to obtain a kind of convergence. This is typically what chemists do. Okay. So in this kind of work, there is no reducibility and deducibility at all. And I have to insist on the fact that a particular level of calculation, a functional of its basis, is specifically designed in order to determine a specific characteristic of the molecules, but not the others. If you want to calculate another characteristics, you have to change the functional, the basis, and so on and so forth. So this kind of tools doesn't allow you to deduce the different characteristic of the molecules by simply one, okay? So here, quantum chemistry reasoning are neither purely holistic, nor purely reductionist. Parts, whole, and surroundings are co-present within this kind of calculations. So on the basis of this study and other points that I develop in different papers and that I will develop in other forthcoming papers, I would like to insist on the fact that the way a chemical calculation is performed involves three actors, whole, parts, and the surroundings, and not two. So you can understand that the holism-reductionism dichotomy, which is mainly based on the prevalence of the whole on the one hand or on the prevalence of the parts on the other, is not relevant to face this situation. There is no room for deducing or reducing something, whatever the meaning of the word taken from Soup, from Nagel, from Schaeffner, and so on and so forth. All those philosophical interpretations don't fit the situation of quantum chemistry. So you cannot use Nagel interpretation and the others as well in order to describe what they're doing. Okay. So a philosophical scenario within which only the whole and its parts are taken into account is not relevant to address the way quantum chemists are working. So if you try to develop a philosophical interpretation of quantum chemistry in which the world prevails or in which the parts prevail, you don't respect what chemists are doing. You are talking about something that the work developed by chemists doesn't enable you to assert. Okay? Sometimes it seems that you have parts and just that the part are enough, you know everything, but it is not the case. Because when you scrutinize what they are doing, at a particular stage of the calculation, they need the whole and conversely. So for chemists, the atomic level is not more fundamental than the others. It is as important as any other in order to achieve the calculation and to provide, for example, an explanation. So Wimsatt non-deductive reduction is also of no avail here, is also no relevant here. So we are becoming aware that the different version of reduction or of holism developed by philosophers don't fit the situation of quantum chemistry. And that quantum chemistry is, in this sense, a spring for developing new interpretation, a new form of philosophy. So I'm very sorry, but Wimsatt here is wrong in this particular domain. And I would like to insist that Lombardi and Labarca have cogently emphasized this kind of question, and that from their pluralist point of view, you have to consider different concepts such as bending, molecular shape, and so on, from their heuristic power and predictive power. Okay. So in light of the above, we consider that the holism-reductionism dichotomy is no relevant in the domain of quantum chemistry, especially when it consists in opposing kinds of prevalence. Donc, this kind of opposition doesn't bring anything to the understanding not only of the ways quantum chemists work, but also of the relationship between levels of integration or between different domains of sciences. For this reason, I recommend to eliminate it from the philosophical debate about quantum chemistry and to develop other kind of philosophical approaches. To conclude, I would like to say that my conclusion are drawn by other authors coming from other domains, and especially from scientific ecology, from biology, such as Dupré, Morange, Bergandi, Gatherer, and different authors also emphasize the mutual dependence of higher and lower level research programs. In these domains, many researchers advocate a multi-level triadic approach, that is to say that which I more simply, in a more simple way, call the world, the parts, and the surrounding. We need the three actors and not two. Thank you for your attention. I do express my gratitude to all the members of our research community, and I sincerely wish you the best in your professional and personal lives.
Thank you, Jean-Pierre, for the talk. We have some questions. Michelle Friend, have a question. Do you want to say it?
Yeah, well, I'm just getting a little bit confused. And it's just a technical thing, which I'm sure you will understand much better than I do. I thought that you couldn't get a notion of shape from topology. And the diagrams that you're showing me of topology look more like topography than topology, you know, so like a map or something. When you're going to climb a mountain, you have a topographical map. Could someone just set me straight and explain to me what topology means here?
Maybe Sheriff, as you have developed this kind of tool, maybe you could give.
I do agree with Michel. I have to turn off the other one. I agree with Michel about the confusion that is in the literature. In fact, the topology comes out of the topography. So when you have this topography that Michel have correctly referred to, you can determine the critical points and the lines, the extrema lines that connect with them, and from that you extract the relevant chemical structure. So in fact, you're correct, Michel, and I capable of having mistaken some of these early in my very early publications, but I corrected it later. So thank you.
There is another question.
Thank you, Sheriff.
Sukumar?
Yeah, so I can, and I often do, take a wave function, a previously calculated wave function or a previously calculated density, and use it to calculate some other property of the molecule. So why do you say that you cannot use a particular calculation to calculate the different properties? I mean, sure, one functional can give more accurate values for one property, and a different functional will give more accurate values for a different property, but that's not a philosophical problem there. That's just a nuts and bolts calculational problem of inaccuracies and things like that.
I am not sure, because you can calculate different characteristics, but you have to do some changes, especially in the basis, especially
I can take the same basis and I can calculate, let's say, dipole moment or vibrational frequencies, which has been the thing, and we do it all the time. We just take the same wave function that has been previously calculated to do a different calculation. I mean, it's just at the level of accuracy of that.
May you give me examples of the different properties, for example, of a particular molecule that you determine using the same functionals and the same basis, please?
Excuse me, can you repeat?
May you give me an example, for example, an example of functional you used with a basis and with a kind of computer in order to determine different properties, and which are those properties? Because when I come to different laboratories of research, I don't see this kind of things. When you read the paper, there are several different tools which are used, and specific tools that doesn't enable you to calculate all the characteristics of a molecule. So may you be precise, please? What kind of molecular characteristic do you obtain from what kind of mathematical tool you use?
For example, we can obtain the dipole moments or vibrational frequencies from the same wave function, right? I mean, these are very different properties. With the same, yeah.
Okay, I'm not sure that you are talking about the same thing, but because we could develop later and after the discussion.
Sure.
Yeah, discuss on a particular example, please.
We will have
Sukuma.
We will have more time in the coffee break. There is another question from Oigan.
So one point is the density functional approach, which is used by common chemists using commercial software, is just a laboratory tool. And it must be distinguished from theoretical chemistry. These are two different things. So also concerning basis, Many people just use the default values for the basis, but a good theoretical scientist would try to increase the basis until the approach has reached its convergent limit.
Mhm.
So, yeah, one should distinguish between what is done routinely by laboratory workers and what is the theoretical concept behind it, and which has partially been lost in the practical work in order to get quick results.
I'm not sure to agree with you here, because the laboratory I am talking about are laboratory of theoretical chemistry, which use different methods in order to explain, to predict, for example, material properties, catalysis properties, and so on and so forth. So I think that in your mind, there is a dichotomy between what is theory on one side and what is a practice on the other side. But as different philosophers have pointed it out, practice or abstract practice, using concept, using mathematical tools, using abstractions, are parts of everyday scientific practices. Abstraction is a kind of practice. In the Critique of Pure Reason, Kant has clearly shown this kind of thing. So when I use the term practice, I don't oppose the theoretical aspects, which more practical one, in the sense that I consider that taking reference to abstraction, to calculation, to concepts, is also a part, is a kind of practice. So maybe the meaning I give to the word practice is not the same you used. I don't oppose practice and theory, because when you do theory, you have to refer to abstraction, which of ways of practicing scientific data, scientific concepts, and so on and so forth. So we have to take care of this kind of opposition, okay? So in my mind, there is no practice on the right-hand side and theory on the other, okay? So be careful with that. The different laboratories I have visited so far are theoretical, mainly theoretical laboratory in chemistry department. So that we can.
So there are too many different types of practices.
Yeah, but I hope that by defining more precisely the way I understand it, I can dissolve the misunderstanding between you and I.
Okay, we have time just for one short question that will be made by Sheriff Mata.
Sheriff.
Yeah, thank you, Jean-Pierre. It's nice to see you after all these years.
Yeah.
So, Jean-Pierre, it's more like a question. As you know, I haven't been trained as a philosopher, even though I have a keen interest on philosophy. A couple of the books behind me are philosophy. But so, to my understanding, reductionism that does not necessarily take the perturbation that the pieces are experiencing by being embedded in the whole, right? But that's not what we meant when Vedor and I wrote that paragraph that you kindly have quoted. What was meant is that they are pieces perturbed by their surroundings already, so it's built in the definition. Perhaps it is not the classical definition that the philosopher used, hence the confusion. Thank you.
Okay. Merci, Sheriff. Thank you, Sheriff.
Merci à toi, c'est bien de te voir.
Ça me fait du bien aussi, je suis content de te voir. It was a real pleasure for me to see you. Yeah. virtual world.
Thank you, Jean-Pierre, for the talk.